All right, so today we're going to focus on long division, synthetic division, all those things to help us find all the zeros of a function. Okay. So now we're into the polynomial land. All right, we've done quadratics so far. We graphed polynomials. Now we're going to solve polynomials, and then we'll get into rationals. Okay. So long division. All right. I don't know how much y'all remember of that. A from elementary school, B from algebra 2. We're going to do that as well. Okay. So first thing you're going to look at is this part right here. You should always have a representative, if you will, for each degree. I can get my mind straight. So if I start with my highest degree, which is 3, I better have a 3, 2, 1, 0. Okay, meaning a constant. All right, so if I started with x to the 5th power, I should have x to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, and a constant every single time. Okay, if you don't, just put a 0 in place. So let's start off with x squared plus 1. And we're going to go into x cubed minus x squared plus 5x minus 9. Okay, once you have that written down, put your pencils down. Especially with division, both the long division and synthetic, as soon as you look down and look back up, I'm on a totally different piece, okay? So we're so used to playing school where we want to make sure we get everything down, and then you're lost on why I did what I did or whatnot, okay? So and you're always going to start with this piece right here. What times x squared gets me x cubed? X. So then I take my x and I'm going to multiply it to both of these pieces. So x times x squared gets me x cubed, and x times 1 gets me x. Notice how I'm going to put that under the one that I'm going to combine it with, okay? The next part is we are going to draw our line and change our sign. So if it was positive, it's now negative, okay? And I add straight down. So here, I get 0. I bring the negative x squared down. This gets me 4x minus 9. Now I start over. What times x squared gets me negative x squared? Negative 1. So negative 1 times x squared gets me a negative x squared. And negative 1 times 1 is a negative 1. I'm going to draw my line, change my signs. That gets me 0. Bring down my 4x. And negative 9 and 1 gets me a negative 8. Is there anything times x squared that will get me 4x? No. So what's that called down there? Our remainder. So we're no longer going to write x minus 1, which is the top part here, our answer, and then like a cute little r and say what our remainder is, okay? We're actually going to add our remainder over what we divided by. Because it did not go into it evenly, we have to write what's left over, okay? Go ahead and take a second to write that down.
Do you care which way we choose to do? Or are we like gonna have to do both?
I don't care, but the problem does. So when you're choosing between long division and synthetic division, you cannot do synthetic division on the problem we just did. It's not possible because it's x squared.
Oh, yeah.
You can only do for a linear binomial. Binomial meaning two terms, and linear, of course, being x to the first power. But other than that, I mean, I don't care either way.
I just remember I had synthetic
Well, we'll use synthetic majority because that's how you want to solve for zeros of a polynomial function. Okay. Any questions now that you've heard it and wrote it down? Okay, so for me, it's easier to use different colors, especially when I'm changing the sign. If you're just using, a normal pencil or anything like that, you can always, if it was a plus sign, you can put a minus sign above it and circle it for your note's sake. I know on a test it doesn't matter, but for just if you're wanting to look back and you're like, why did that just automatically change its sign? Okay, you can always do that as well. Okay. So the next problem down here, go ahead and do long division to that one, and then we'll go over synthetic. Okay. What's missing in this one? X. So make sure you put a 0x. Must have got rid of the little camera thing. Ah, there it is. That's what I need. Sorry, this could be loud for a second. I always hate that you have to do all this on a Mac. Oh well. We'll just write down here. All right, so like I said, you're gonna have to add in a 0x. So if we have x plus 2, and we're going into work.
You just erase the one.
In case someone else is still looking at it or writing stuff down. All right, so what times x is going to get me 3x cubed? 3x squared. All right, so 3x squared times x gets me 3x cubed. And then 3x squared times 2x gets me 6x squared. Draw my line, change my signs. So that gets me 0. This gets me a negative 10x squared. Bring down my 0x and my 5. I start over. What times x gets me negative 10x squared? Negative 10x. So negative 10x times x gets me negative 10x squared. And negative 10x times 2 gets me a negative 20. That's why I have y'all putting a placeholder in there, so that way when you get to this spot that you line it up with the one that you're combining right terms with. I don't want y'all to add it with the 5 and accidentally get 25x. Again, things happen. Draw my line, change my signs. I get 20x plus 5. And what times x gets me 20x? 20. So I get 20x, and 20 times 2 gets me 40. And one last time, I will draw my signs, or draw my line, change my signs, and I get negative 35. So to write my final answer, I'm just going to write 3x squared minus 10x plus 20 plus the negative 35, or you can do minus, it doesn't matter. Whatever it couldn't go into evenly, which is that x plus 2. Okay. Any questions on that? Okay. So synthetic division, we're going to do the same exact problem, but using synthetic division. Write it over here so I can write it on another slide. These are old notes where I used to type up notes for kids, like what are those called? Guided notes. And then it was easier just to take screenshots of the problems and it uploaded up here. So this is all one thing. That's why I'm not able to separate it out. Eventually I will, yes, but right now, no. And it always happens every time I come to this lesson that I'm like, I should have done that, and I haven't. So That's where we're at. All right, so same thing, but we're going to do synthetic division, okay? So you're always going to take that denominator, whatever you're dividing by, and set it equal to 0. That is what goes in the little box, okay? So you're going to take the denominator, set it equal to 0. It is your 0, right? Your solution, your 0, your x-intercept, your root of the function. And we want to see if it goes into evenly. Well, it might not be the 0 root function. We'll look at that here in a second. And we're just going to write out our coefficients. You have to have that placeholder 100% here, or you will get it wrong. You could probably get by with a long division, but this one you cannot. So you have to have that placeholder. All right, once you have that written down, put your pencil down. Because this one, literally, when you look down, I could be done with the problem. If I went at the normal speed that you go, but I'm going to go slower just to walk through it. Okay? So, always, 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 you're going to bring the first number down. Okay? So if you're down here, we're multiplying. If you're up here, we're adding. So like I said, hold tight. You can write it down afterwards. I want y'all to watch. Okay? So 3 times -2. -6. Add straight down, we get -10. -10 times -2. Add straight down, and 20 times -2. When we add straight down in the last spot, that is going to be our remainder. So if you notice, this looks very familiar, okay? So if we are dividing an x cubed by an x, okay, old exponent properties tell us that we just get x squared, okay? Another way to look at it, always just go 1 degree less, okay? So this is x squared, this is x. So we write out our answer, and it's the same exact as the last one. You can only do synthetic division when you have a linear binomial. Any questions on that so far? And we're going to do some more examples of synthetic division because that's mostly what we're going to be using because that finds the zeros of the function for us, okay? All right, so you're going to see something in your notes, or in your homework, that is going to ask you to use the remainder theorem. It's going to seem so silly to do something twice. That is what they're asking you to do. But when you're looking at the remainder theorem, what I want y'all to do real quick, whether it's by hand or with a calculator, I want you to type in, or again, like I said, or solve 3 times -2 cubed minus 4 times -2 squared plus 5. Do what? What'd you get? So if you notice, that is the same exact remainder that we had for that problem. I took what we had in the little box, which was that -2, and if you plug it back in for x, the answer that you get there is going to be your remainder. Again, it's kind of like the discriminant when you're doing the quadratic formula. It doesn't tell you the answer. It tells you what it is going to be like, if you will. Discriminant told you how many and what type of solutions you were going to have. So the remainder theorem is not necessarily telling you the answer of the problem, but it's going to tell you if it goes into it evenly, right? Because what would you get here if it was a 0 of the function, or a root, or a solution? 0. Same thing as if your remainder ended up being 0, you would know that it went into it evenly, okay? So the remainder theorem, what they're just going to basically have you do is they want you to do synthetic division, or long division if you prefer, get a remainder, and then they want you to do this part too and show, ooh, you got the same thing. Okay, so when y'all come across that and it says use synthetic division and the remainder theorem, that's what they want you to do. So for some reason, a lot of people get confused about that question on the homework, so that's why I made sure to go over exactly what that means. But they just basically want you to see the remainder theorem is basically saying I can take that value and plug it in for x, and it's going to give me the same thing as my remainder. Doesn't give me a solution, just tells me the remainder. Okay? So that's a quick way to check if something is a factor. Okay? So you have something like the next question where you can either do synthetic division or plug in that value into the calculator. Now, if it's on the non-calculator portion, I would probably suggest doing synthetic division. Especially if you had to do 3 to the 4th power times 8 and so on. Now, if that's easier for you, you can do it that way as well. But either way, I need you to tell me if this is a factor or not. And how you're going to do that is you're going to either use synthetic division or the remainder theorem. And if you get 0, it's a factor. Go ahead and pick your poison. If you want to do remainder theorem,
If it's 0, it's a factor.
or the synthetic division. Do it.
Again, those maybe.
That would again.
Why do I keep
It
hearing?
sounds similar.
Do
I guess too. I don't know. What was your question? I'm sorry.
He answered it.
Maybe that's what I saw or heard.
Do you want me to change my cadence? So we don't
No.
miss it?
Yeah.
No, thank you.
We have 3 octaves.
It's hard when you've got one ear clogged and you can't hear out of it. So, and all I can hear is like deeper voices are like more. And they all sound the same. So
I also kind of.
That's also a product
Yeah.
of being old.
it's okay. A lot of people mumble,
Yeah.
which makes it real hard to read lips.
I mean, I mumble, but I mask on, so.
Mask on are harder for me too.
No, I mumble.
notice how we are missing x cubed, so that needs to be a 0. All right, so 8 times 3. 24. 24 times 3. 72. 70 times 3. Okay, so already I'm noticing I am absolutely nowhere near 0. Okay, but I'm going to keep climbing. All right, so if I take 215 times 3, 645, yeah. And we get a remainder of 644, okay? So, by the factor theorem, here in this case, I can look at this and the fact that my remainder is not 0, it is not a factor, okay? So I would say, no, it's not a factor because the remainder doesn't equal 0, okay? So just because the remainder doesn't equal 0, it did not go into it evenly, which means it is not a factor of the polynomial, okay? If you just plug it in, I would ask that you put by the remainder theorem because again, that's showing that that is what that is. But if you do synthetic, then you could say, well, the remainder's not 0, therefore, okay.
Is there like an easy way to tell by just looking at it if it's going to be a factor? Or it's just could be like
No.
Yes.
it is.
Yeah, there's not a perfect way for it. All my failed attempts there to do that. Okay, try the top one.
No, this is a matter of flipping way. This is a factor. It is a factor.
All right, so we're missing 2 pieces here. We're missing an x cubed and an x. So I have to put a placeholder in for both of those. So if I bring down my 4, I get 8. 8 times 2 gets me 16. I get a 1. Down my 2. I get 4. And I have a remainder of 0. So yes, it is a factor because the remainder equals 0. Okay? Any questions about those 2 theorems?
Look at the exclamation mark every time.
Okay, you both talked that time. Okay, so what was your question?
Would this mean, okay, so no, I don't know if this makes sense. Would this mean if you multiplied x minus 2 out of 4 times, you would get that or no?
No, what it means is x minus 2 times all of this would get you that.
Oh, okay.
Dang, what was your question?
I just thought I'm gonna put the exclamation mark every time.
Good.
I'm gonna put, no!
You should do a question.
Yes!
No, I just did a comma, so.
No. Yes, it is a factor.
Yeah.
Go back to comment 4. I like the explanation.
Okay. Let me. Okay, so the fundamental theorem of algebra is, something that's supposed to be very extreme. It's not. Okay? It's basically, instead of using all those words, I would probably put down the highest degree is how many solutions you're going to have. Womp womp. Okay. So the highest degree that you have, so if it's x to the 7th power, you are going to have 7 solutions, whether they are imaginary, if they are real, if they are rational, if they are irrational, all the things.
If they're all the same, does it count?
They're all the what?
If they're all the same, does that count?
Yeah.
Okay.
Yeah, it's just saying the highest degree possible is how many solutions you're going to have. No matter what type of number it is there. Okay? All right. However, the rational zeros theorem, let me get rid of, I don't know if it'll let me or not. I want to color on that. And it's not letting me color. Ooh, here's what we'll do. It's supposed to draw the box. Nope, it does not want to let me do anything, apparently. Not even a heart.
You do the things where you like tap the corners.
It doesn't like me today. Doesn't even want to let me use the creative pen. Okay. There you go. All right, so the rational zeros theorem, okay? Basically, before you had the calculators that you have, because there was a time that those did not exist, you would have had to find all of the possible rational zeros of a polynomial. Then you would have to take every single one of those and do synthetic division to it to see if you got 0 as a remainder. Okay? Then, once you did all of that, then you could break down the equation and find the rest of the zeros. Okay? So in some cases, if you have luck like me, it's probably going to be the last number that works or something like that. You've done like 50 others, and it's the last one you plug in that actually works. Okay? And then the next one you start at the end, and it's the first one. You know how that works. Okay? So this is still something that you have to learn, but you don't necessarily have to apply it because you have your calculator, okay? But it's still something that is tested, all right? Which is weird, but we say thank you when we move on for things like this, all right? So to find all the possible rational zeros, you're going to put all of your constants factors over your leading coefficient, okay? So factors of the constant over the factors of your leading coefficient. Okay? They use P and Q in your book. That's why it's P and Q over there. But it's easier to write out the letters that you're actually using. So it'll help you remember. Now that it's come back, and Netflix is also a thing too, but now that it's come back, the hills in Laguna Beach, there's a girl on there that's called Lauren Conrad. Used to be a show that I would watch back in the day. But I used to always say, is it possible, because it's going to ask you for the possible rational zeros, is it possible to call Lauren Conrad? And that was an easy way to remember. But then we kind of had to change the initials because a lot of people still probably don't know who Lauren Conrad is. So pick whatever initials you want. But it just helps you remember which one goes on top and which one goes in the denominator. Okay?
I gotta know the face.
I will. She's cute.
I would assume that.
Does that matter?
Does it matter?
Like, does that matter?
It makes you remember. Yes.
Yeah. Of course it matters.
I didn't mean to strike a nerve.
She has her own clothing line. She has her own clothing line. She was on the Hills, Laguna Beach.
I just think of Conrad from
You can think of Laura, isn't it Laura Croft or whatever?
Laura Croft, Tomb Raider.
It's like the inferior treasure hunter.
Yeah.
That's the girl from
Or just learn the math lingo. I don't know.
It's Tomb Raider, but it should be like Tomb Layer. Like she should just go lay in the tomb.
So, for number 4,
Yes.
all it asks for is the possible rational zeros. Okay? So I'm going to do my factors of my constant over my leading coefficient. So, you have to include plus or minuses. And then after we write this write this out, we have to then finally write our answer. So this first one is really nice. Okay? They can get really mean. And it depends on how many numbers you have. So all the numbers that go into my constant are just, thankfully, 1. Okay? So then I would just include plus or minus. You're going to include plus or minus with every number. Okay? And then all the numbers that go into my leading coefficient, which is 3, are going to be 1 and 3. So like I said, this one's real nice. All right, so to write your final answer, you're going to write 1 over 1, which is just 1, and 1 over 3. Okay, you have to write out all your numerators over all of the denominators. Okay, so like I said, this one's real nice. But that already has you doing synthetic division 4 times if you had to actually apply this. Okay? I'm sorry?
You said 1 over 3, but wrote 3.
Oh. I think I was writing right when I said 3, so that's why it was just 3. So like I said, back when you didn't have your calculator, then you would have to do synthetic division those 4 different times to see if you got 0 as a remainder. And it could be at the end of all of it that none of them worked because maybe you have an irrational number or something like that that went through. Okay? So let's look at the next one. Again, still not as mean as it could be, but does require a little bit more. Our constant is 2, so all the numbers that go into 2 are just 1 and 2. And our leading coefficient, we've got 1, 2, 3, and 6. So I'm going to take 1 and I'm going to write it over all of the denominators. Then I'm going to take 2 and write it over all the denominators. You don't have to repeat any numbers. So like 2 over 2 is 1. And we've already claimed that one. So you don't have to repeat anything. So I've got 1, 1/2, 1/3, and 1/6. 2. 2 over 2 is 1. We don't need that. So then 2/3. And 2 over 6 reduces to 1/3. So now we're up to 1, 2, 3, 4, 5, 6, 12 different times you would have to do synthetic division before even starting the problem. Okay?
Why would they do this? I can't calculate. I don't know. Is it?
So how this is tested, this is a separate question. Okay? So you just have to know how to do this for one question on the test. All right?
We're never gonna have to like actually do this for synthetic.
Do it now.
We're never gonna actually have to like solve the whole problem.
You will, but it will be with a calculator. So like some books, they even have this, because what it is you're starting with this, and then they have you find all the possible zeros, and then they have you do the synthetic division for all of them until you find one that works. But if it asks you to do that, you just say, here are all my possible zeros, and then you move to your calculator and you start doing what we're about to do. But on the test, it just asks, what are the possible rational zeros for this function? And that's all you have to tell me, and that's it. Okay, so let's find all these actual zeros. Go ahead, and if you do not have a graphing calculator, go ahead and grab one. Okay, so in y equals, go ahead and type in that first equation. All right, so my highest degree possible, or my highest degree that I have here is what? 3. So how many solutions should I have? 3. Okay. Now, if this happens on the test, you say thank you and you move on. Okay, I'll write down the answer and then say thank you and move on. Because all 3 are in your calculator. You can go to your table to confirm. But all 3 solutions are already there. We have -3, we have -1, and we have 2. If that's the case, you're done. Okay? But let's say it is on the non-calculator portion of the test. Trying to give you all kinds of scenarios that could possibly happen. It's on the calculator portion, plug it in, and get started from there. If it's on the non-calculator portion, I will give you enough zeros to get you down to a quadratic. Okay? So I might give you this same exact problem, and then off to the side I might tell you, and one of the x's is 2. Okay? One of your zeros is 2.
Can't you just get that from factoring?
From factoring this? Can you know how to factor that? If you can factor it, 100% do that. Okay? In this particular case, like I said, if it's on the non-calculator portion and I tell you that one of your zeros is 2, but I didn't give you the others, and you don't have a calculator, this is how you would approach this problem, okay? So go ahead and do synthetic division with the 2. You will either have your calculator or I will give you enough zeros. You will never be stranded without any of that information, okay? Stranded, I mean, you could do all the possible rational zeros, but I'm not even making you do that. So if I tell you it's a 0 or a root of the function, then you better get 0 as a remainder. If not, you might want to go back through and double check it. Okay? So after we do synthetic division, we are now down to x squared plus 4x plus 3. What are factors of 3 that get me 4? 3 and 1. Set those equal to 0. There's our -3, -1. Okay. So if you are given a calculator, great, use it. If you are on the non-calculator portion, I will give you enough zeros to get you down to a quadratic. Now, in some cases, your quadratic you'll be able to factor. Some cases you'll have to do the quadratic formula. Some cases you'll get an imaginary number. In some cases you'll get an ugly radical of some sort, okay? But the process is going to be the same. We're going to plug it into our calculator, if we're allowed to. We're going to get any of the zeros that they give us. We're going to use synthetic division to break it down, and then we'll solve for the rest of the zeros after that, okay? These problems are problems that you are able and you are capable of doing each step. It's just when it's all thrown together, I think that's when it gets a little confusing for people, okay? Because we've done quadratic formula. We've factored 100 times. Synthetic division, y'all proved that it was pretty quick. But for some reason, when it's all thrown together, it gets to be confusing. So go ahead and plug in the next one into y equals. Always check your graph first and then confirm with your table if it crosses through somewhere. So, in some cases it works out in your favor, in some cases it doesn't. Never trust a bounce or a touch on the x-axis. And what I mean by that is you could probably zoom in for days, and sometimes at one little point it might dip below and come back up. All right? That's why I said check your table in your calculator. And then also we're given 1 0 from our calculator, and that's plenty enough to break us down to a quadratic. Okay, we could assume if we wanted to that, okay, well, I already know the 0, I can do the 0 function, all that stuff or whatever. But again, we're going to come across some that's not even going to be available for us. So we do know that the calculator gives us 3. So go ahead and do synthetic division, break this down, and find my other 2 zeros. Just a heads up, we're going to have a quiz on Wednesday. And it's just strictly going to be about the quadratics. the graphing the quadratics, and graphing polynomials. It's not going to have any of this new stuff on it. Just graphing quadratics, graphing polynomials. So we can't do the shortcut factoring this way. We have a leading coefficient of 2. I'm going to go over factoring this way again. So 2 times 3 gets me 6. I'm looking for 2 numbers that multiply to get 6 to add to get negative 7. What are they? Negative 6, negative 1. We're going to use those to bust apart the middle. The leading coefficient stays the same and the constant stays the same. We're going to group together the first 2 and then the last 2. Greatest common factor in the first set. 2x. When I divide that out, I get x minus 3. Greatest common factor in the next one. Negative 1, so I get x minus 3. So what do I see double of? X minus 3, and then 2x minus 1 is what's left when I take that away. So, granted your calculator, you could probably find that out, but I'm just showing you there's going to be situations where we're not going to be able to use our calculator, so it's best to get the practice in solving these without, okay? So, the highest degree possible was 3. The calculator gave us one of them. We ended up with a double root, but like I said, don't trust the bounce, because in some cases, it goes just a little bit underneath the x-axis, okay? So we ended up with 3 and 1/2, and that gave us our third zero, okay? Any questions on that so far? Do y'all remember this a little bit? A little bit? Somewhat? Meh, we don't need to do all that. Okay, so your homework, y'all can go ahead and get started on it.